Question 20 is algebraic fractions, but with any fractions, whenever you divide fractions, let's just think about one where you've got numbers involved. Whenever you're dividing fractions, you're always going to turn it into a times and flip the second fraction. So in this case, that would end up giving you 27 over 20. So when it's algebraic, it's the same. Our first step, I'm try and keep this neater than I normally do. You turn it into a times and you flip your second fraction. Now let's factorise each of these bits as much as I can. So this top bit over here, in fact, when you're timesing, it's all just you're gonna end up timesing across the top and timesing across the bottom. So let's just do it all in one go. I've got 3, that can become 3 lots of x plus 2, and then x cubed minus, actually I'll keep it separate for now so you can see what's going on. That would become x squared minus 25. If I factorise this bottom quadratic, two numbers that add to give you minus 3 and times to give you minus 10, minus 5 and plus 2. And then you've just got x plus 5 down here. Just to the side here, x squared minus 25, this is a difference of 2 squares. So actually, if I times across the top, I'll put the 3 and the x together. And you've got x plus 2. And the x squared minus 25 can become an x plus 5 and an x minus 5, because it's difference of 2 squares. And along the bottom, we've got x minus 5, we've got x plus 2, and we've got x plus 5. Right. Because these are all being times together, think about simplifying fractions. The reason why you can simplify 6 over 9 to 2/3 is because the top bit is 2 times 3, and the bottom bit is 3 times 3. And because they're being multiplied together, you can cancel these factors out and just get 2/3. So because there's no plus or minus signs in between any of these, they're not different terms, there's no pluses or minuses, they're all just being times together. It allows me, just like I did up here with the numerical ones, I can start cancelling. Like here, if you want to think of that as I divide the top by 3 and I divide the bottom by 3, let's divide the top and the bottom of this by x plus 5. Let's divide the top and the bottom of this by x minus 5. Let's divide the top and the bottom of this by x plus 2. And all I'm left with is 3x. And the question says, show that it simplifies to ax, where a is an integer. Well, a is 3. You've got your integer. Let's do question 21 at the same time. So, you've got x squared is greater than, let's expand the brackets, 3x plus 18. If I bring this all over to the same side, when you're trying to solve an inequality, you can, just for a little part of the question, you can set it as if it's an equation, set it equal to 0, just so that you can factorise it and get your critical value. So if you were solving it, you'd have x is 6 and x is minus 3. Now, some of you have a tendency to do that and then just look back, see it's an inequality and randomly throw in some inequality signs. What you want to do, if it's a quadratic inequality, you always need a sketch. I've said this so many times before, some of you still don't do it in exams. So this quadratic cuts at minus 3 and 6. The x squared graph is shaped like this. So if we want our quadratic, looking back at the inequality bit, if we want our quadratic to be greater than 0, we want the bits that fall above the x-axis. To stay within that region, you need x to be less than minus 3. You need to come down this way from minus 3, and you need to go up from 6. So you need x to either be less than minus 3 or greater than 6. They are the conditions with which the quadratic will stay above 0, above the x-axis. And you want your quadratic to be above 0.